Hello, today we're going to be talking about finding the centroid of a 2D shape via the first moment integral. So starting with what is the centroid? The centroid of a shape or a volume is going to be the point that represents the geometric center of that shape. So this is going to be important for a number of reasons. In a uniform density part, this is also going to be the center of mass of an object. So if I imagine a cone, it's made all of one material. The centroid and the center of mass are the same point. It's going to be one of the big pieces. And it's also important, centroids in 2D in particular are important for beam bending and the torsion of shafts as well. Alright, so centroids in 2D. To find the centroid of a 2D shape, we're going to be using obviously a 2D moment integral. It's the first rectangular area moment integral. So first we're going to be using a distance term, a single distance term, not distance squared. Rectangular, we're going to be measuring out from the x and y axes. And area moment integrals, we're going to weight all of the pieces, all of the little bits of area in our shape equally. So, since the centroid is a point which has both an x and a y coordinate, we're going to have to do this calculation twice. We're going to need one to find the average x coordinate of our shape and one to find the average y coordinate of our shape. So this is going to be x bar and y bar is the x and y coordinate of our centroid. So, to find the average x coordinate, we're going to start with that. Of a set number of points, so we're doing with kind of the discrete point here, we would add up all the points, or add up all the x coordinates of all the points, and simply divide by the total number of points. This is simply just the average calculation. So the average x value is the sum of all the x values over the number of points. With our average x coordinate of an infinite number of points, we need to convert this into an integral. We integrate the x coordinates over the entire area, and then we divide by the total area. So x bar is simply going to be the integral of x dA over the total area. And this is our equation that we're going to be using. So let's talk a little bit more about each of these terms in here. So x bar, that's the x position of our centroid, that's what we're going to be looking for. We're taking the integral from the lowest x point out to the highest x point. So the lowest x position is the leftmost point on our shape. And so I've got kind of this parabolic shape here. So x minimum is over here. X maximum is over here. And these are simply measures. So we're taking it from a definite minimum and a definite maximum. dA is probably the most important part of this. So dA is the rate of change of area as I move along the x-axis. So as I move out along this x-axis, the rate of change of area would simply be the height of the body times the rate at which I'm moving left to right. And so as I start out, the rate of change of the area goes up and it's going to go back down. So I need to write out an equation describing the height of the shape at any given value of x. And I plug that in for dA, and I multiply that by dx, because I'm taking the integral with respect to x now. And I multiply this whole thing by x, it's just the term x there. And finally, the total shape of the area, you're going to need to find that. And after you take the moment integral, you divide by that total area. So this should give you the x position of your centroid via this first moment integral here. Alright, so finding the centroid in the y direction, y bar is the y position of our centroid. Again, y minimum, now we're moving up along the y-axis, so we start here at the bottom, and y maximum, we move up to the top. dA is going to change a little bit, so now we're moving along the y-axis as I move from the top up to the bottom. Rather than the height of my shape as I move left to right, I'm going to take the width of my shape as I move from top to bottom. So dA is going to be an equation describing the width of the shape at any given value of y. And so you might need to do a little bit of geometry and think a little bit about what that function is. You multiply that function by the term y, and then again you take the moment integral, divide by the total area of our shape, and that should give us our y-coordinate of the centroid. So with that, it's really as simple as this. There are other alternatives. If you find the calculus gets a little bit difficult, we can use a kind of the method of composite parts. But this is how, kind of on a base level, all of these centroid coordinates are found. So with that, that's all I have for this lecture. Thank you for watching, and I hope to see you again.